Hello, this is Mrs. Hanvey, and we're going to do our lesson on solving absolute value inequalities. Our central question is, what are the differences between solving absolute value equations versus inequalities? So by the end of this lesson, you should be able to solve an absolute value inequality algebraically. And tonight's assignment is going to be on delta math. And you should be able to click on that link and it takes you directly there. All right, so the first slide is our steps. So please make sure you write these steps down into your notes. That way, when we take a test or a quiz, you can go back and reference them. So the first step to solving absolute value inequalities is exactly like what we did before. You're going to isolate that absolute value. That means get it all by itself. The second step is to split the equations up. The only difference, and this is going to be the new part, is when you do the absolute value inequality, you're going to flip the symbol and change the sign to a negative. So if the original problem was less than, you're going to flip it and make it greater than. And you're going to change the answer to a negative. So when we do an example, that will make more sense. When you graph them, you're going to have two possible answers. It could be an OR problem with two arrows going opposite direction, or it's an AND problem where you shade between the two dots. And so I just wanted to refresh your memory. Here's how you know if it's a less than, if it's going to be an AND problem, or if it's going to be a greater than OR problem. So it's kind of a play on words. Less and, great or. So that's how you know if it's going to be an AND problem where we write our answer as one inequality, or it's going to be an OR where you write it as two separate inequalities. And remember here, if you have a line underneath the inequality where it's equal to, so either greater than or equal to or less than or equal to, you're going to have a closed dot. If you do not have that equal to underneath the inequality, it is going to be an open dot, an open circle. That's why these ones, they no line, they have open circles. This one has a line, equal to, has a closed dot. All right, so let's do example number 1. Make sure you copy these into your notes so you can go back and reference. The first thing I always make sure I do is I look at my inequality and I determine whether or not it's an AND or an OR problem. So just think to yourself, this is less. So is less going to be an AND or an OR problem? So it's kind of a play on words. Less and. And so now step 2, it's actually step 1, but I kind of like to just make sure I know if it's AND or OR. Our next step is going to be get this absolute value isolated. That means all by itself. So hopefully you realize that we have a number in front of that absolute value. It's not all by itself. So this is 2 times the absolute value. So we're going to do the opposite, and we're going to divide by 2. Divide by 2. And when we divide by 2, then we get that absolute value all by itself. It's isolated. And then we're just going to have less than 13. Now, this is where that's new. Whenever we have an inequality, you're still going to write the problem twice. I'm going to leave a little spot there and put 13. The one on the right, I just leave absolutely alone, exactly as it's written here. I write it down. I just don't put the absolute value anymore. But on the left side, what I like to do is you have to not only make this a negative, but you also have to flip this inequality. So it was less than, we're going to flip it, and now it is greater than. So you have to do both of those cases. You have to make it the answer negative, and you have to flip that inequality. So if you're going to make a mistake, that is probably where you're going to make it. So don't forget, you got to flip and make it negative. All right, so now what we're going to do is we're going to solve this just like normal. Subtract 4, subtract 4. So x is going to be greater than negative 17. Subtract 4, x is going to be less than 9. And remember, we already know this is an AND problem. So we're going to go ahead and graph it so it's a little visual of how to get your answers. What do you know your answers are? So we're going to put negative 17 on the left side because that's the smaller number. Hence why I put this equation on the left because it's smaller. And then this is going to be 9. We're going to put 9. And we know 0 is like somewhere over here. All right, so we know that there is not an equal to underneath that absolute value. We do not have that line. So we know we're going to put an open circle. So we're going to put an open circle on negative 17 and at 9. And we know this is an AND problem. And so we want all numbers greater than negative 17. That's going to be this direction. And we want all of our answers are going to be numbers less than 9. And that's going to be in this direction. So anytime we have an AND problem, it's going to be shaded in the middle. So those are all of our answers. Those are all the answers that will satisfy that inequality. So 0 is an answer, negative 15 is an answer, 1 is an answer, 8 is an answer, 10 is not an answer. Negative 17 itself is not an answer. That's why we have an open circle because it's not going to work. If you plug it in here, negative 17 is not greater than negative 17. It's equal to. And so that's why we use an open circle. All right, so when we write our AND problems, you have to write it as one basically inequality. So here's what you're going to do. You're just going to bring this part down. X is going to be less than 9. And you're going to put negative 17 on the side, on the left side. And we know that this arrow points to the negative 17. So we're going to keep it pointing to the negative 17. So this is how you would write your inequality as an AND problem. So what I need you to do now is after this video ends, I want you to go to this problem and I want you to try it yourself. And so I'll wait for a few seconds so you can write it down, and then I'll go back and go over this problem with you. Thank you for watching.